Okay, hello everyone. My name is Prashant Agrawal and I'm working as Senior Analytics Specialist SA in AWS, where I primarily focus on Amazon OpenSearch service. And today I will be talking about how to optimize cost with tiered storage in Amazon OpenSearch service. So before getting into the storage tiering, let me take a step back and talk about what is Amazon OpenSearch service. So OpenSearch service is a fully managed service that makes it easy to deploy, operate, and scale OpenSearch along with legacy Elasticsearch cluster in AWS cloud. Let's take a quick detour and see what exactly OpenSearch is. So OpenSearch is a community-driven open source search and analytics suite which is derived from Apache 2.0 licensed version of Elasticsearch 7.10.2 and Kibana 7.10.2. So OpenSearch is a rename for the Elasticsearch, whereas OpenSearch Dashboard is a rename for the Kibana. Talking about the data, here is some numbers where worldwide data is expected to hit around 175 gigabytes by the end of 2025. And out of those 175 gigabytes, 90 gigabytes, that is around 50% of data is expected to be generated only from IoT devices. Out of all those IoT data, 80% of these data set is unstructured, where 71% enterprise reported that unstructured data is growing way faster than the business data. So let's see what are some common sources for these data sets. So when we talk about application, you can have data being generated from various sources such as microservices or maybe web application or business application, or it may come from various APIs. Then in DevOps world, you might be running databases, load balancers, or various servers, which might be generating system logs you would like to store for analysis. And at last, we have many IoT devices such as automotive or home devices, wearable devices such as smartwatch or sensors, which could be used in manufacturing. So on the application side, you would like to know if your applications are up and running and serving the request with low latency, and if there are any errors, you are able to troubleshoot the issue by analyzing those logs. Then on the security side, you could use security logs, which could help you to identify if there are any suspicious activity or suspicious login to your application. It could be like from what location your application is being accessed and make sure there are no fraudulent activities happening across your applications. Then lastly, onto the observability side, it helps you to get insights into your infrastructure and troubleshoot the problem in near real time, which basically directly influence the overall customer experience by building the resilient apps, which can reduce the downtime at the end. So as data grows, the cost of storing these data grows significantly as well. And when we talk about log data, you might not need all the data to be accessed with low latency. And you might want to retain the infrequently access all the older data at scale, but that could be cost prohibitive. Also, you cannot perform the same analysis on data that is months or even years old and with the one which you can do with the hot data, because old or infrequent data is query intensive and you would want to reduce the impact of such query intensive data on your production cluster. But what if you need to store those data for longer duration, maybe like you want to archive those data for regulatory or the compliance purpose? So in this case, different storage tiering with the open source service can help you to save a lot of cost by getting the performance at the same time. So let's talk about what are the different storage tiering. So basically, there are three storage tiers: hot tier, ultra warm tier, and the cold storage. So hot tier enable you to keep the recent data readily accessible and indexed in high performance storage to enable querying and conducting real time analysis. With ultra warm and cold storage, you can keep older data still available for the analysis into the lower cost block storage or maybe durable storage like S3 with some trade off between the performance. So we will dive a little bit deeper onto different storage tiers and let you know that how it can help you to reduce the cost. So talking about the ultra warm, this feature was launched in May 2020 and it has got a lot of traction from various customers. One of the reason is cost, where in some cases you can save up to 90% of the cost when you store data with ultra warm. Then ultra-warm nodes are optimized for caching and running the query for data stored into the S3, then these queries are fast enough to run interactive log analytics or maybe plotting the visualization and dashboard. With a single OpenSearch service domain, you can store up to 3 petabytes of data. And the only trade-off between the hot tier and ultra warm is that data stored into the ultra warm is immutable. So you cannot modify the data when it is into the ultra warm storage. But if need arises, you can bring back those data to the hot tier, perform the updates, and send back those data again to the ultra warm. Now, talking about the cold storage, this feature was launched somewhere around May 2021. And basically, it decouples the data stored into the S3 to the compute node running on ultra warm data nodes. With cold storage, you can virtually store any amount of data because you are just archiving it to S3 and pay the near about S3 pricing for the same. Then we have the index state management policy, which I will be talking in detail in my next slides. But you can use those policy to move data automatically from ultra warm to cold tier, or maybe like even from hot to ultra warm. Then we also have the OpenSearch dashboard, which has a discovery UI where you can easily see all the indices into different tiers, like what all indices you have into hot, ultra warm, and cold. And at the same time, you can move those indices from one tier to other. Then talking about the trade-off, so only trade-off with cold storage is that data into this tier is not searchable. So if you want to run any search on those data, you need to reattach the data to ultra warm nodes. And this is really a good feature for archiving purpose if you would like to store data into durable storage for longer duration. Now, talking about the index state management, it is a feature which was released in March 2020, and this makes it easy for customers to manage recurring index management activities and save time. In the past, you might have to use additional tools such as curators to manage the data lifecycle policies, but using this tool, you do not really need to maintain and manage any separate tool. And for example, you can set up daily indexes for operation logs to send data to OpenSearch, where your data gets indexed and is stored into the hot tier. And after that, you might need to roll over those data to the warm tier depending upon the retention. So maybe say you would like to store data for 30 days into the ultra warm tier. And after 30 days, you might want to send all those data to the cold tier and store it maybe for another year for the archival purpose. And then at the end of the life cycle, you might need to delete the data completely from the system and free up the space. So in short, using index state management, you can now create a policy that will automate all the operations based on like index size or index age and some other conditions, and that you can do within your Amazon Open Source Service domain itself. So this is a sample or an example policy which we will be using into the demo. So what it talks about is like it says like your default state is the hot state where your data gets indexed actually, and then your data gets transitioned to the ultra warm stage after 3 days, and then after 90 days those data move from the warm to the cold tier. And then at the end of the life cycle, you can delete the data after 365 days. So that's roughly an year. So this is an example policy. I will drop those data into the text as well while we are adding those videos. And next, let's move to the demo. So we have seen what are different storage tiers and how ISM could be used to define the data lifecycle. So let's quickly jump and see how these things really work in Excel. So for this demo, I have logged into the OpenSearch dashboard. Then from the left side you can click on the hamburger icon and then go to the index management tab. Then index management displays all the index state management policies. So I have one sample policy which I will be demoing into this particular session. So that talks about how you can create the policy for the hot, ultra warm and cold storage. So you can open that policy and see what all details it has. So it needs the ISM template, which is nothing but your index pattern. So my all index starts with Octank IoT logs. So that is my ISM template or the index pattern for this particular policy. Then it has 4 different state. One is the hot state, other one is the warm, then cold, and then delete. And then if you look onto the each of these states, then you can probably view the JSON for this particular policy, and it talks about your default stage is the hot state, and then you are moving the data from the hot state to the warm state after 3 days, and then from warm state to the cold state you move those data after 90 days. And then once data is there into the warm state for 90 days, you are moving those data into the cold store, and then you store those data for another 365 days. And once your data life cycle expires after 365 days, then you delete the data and then send a notification on the chime as well, so that you will be alerted whenever any delete operation is happening onto that particular index. So this is how you can specify the policy using the JSON. And if you click on edit, then you have another option as the visual editor as well. And if you click on visual editor, then it lists down all the states what you already configured, and then it gives you an option to either modify that or make any changes onto this particular stage. So like this is your initial stage, and what you are doing is you are just migrating those data into the ultra warm after 3 days. And when you look at the warm state, so you are just migrating those data from warm state to the cold state after 90 days, and then into the cold state you store the data for 365 days, and then you delete the data. Then into the delete state, you can see we are actually running the cold delete operation, which deletes the data and then sends a notification into the Amazon Chime as well. So you have two options: either you can configure it using the UI, or you can configure it by writing the JSON. Now this page also lists down all the indices what you have into the different storage tiers. So if you click onto the hot indices, let me add a filter for Octank, as these are the indices what I have. So you can see all of my hot data is only there for 3 days. So 23rd June is the current date, so it's still getting the new data, but older data is only there for 2021 and 22. And then if you go to the warm stage, you have all the data from 19th June until last 3 months. So basically the oldest data what we have is from 26 March. And then when you go to the cold indices, then you can see all the data is there, which is basically from the 25th March until last 1 year. So in this way you can see all the data, and then you can either use the API to migrate the data from one stage to other when you want to run any operation, or you can use the UI as well. So first let me show how you can use the ISM API to migrate the data and search the data onto the hot tier. So you can, for example, I have the data for 21st June, which is into the hot tier. You can run the query on that particular data and you get the response. Then all of my May month data is into the warm tier, because you have seen like I'm moving all the data from hot tier to warm tier after 3 days, and I can still run the query onto all the warm data. But now if I try to run the query onto the cold data, so basically all of my January and February data is there into the cold storage. So if I just change the query to run the data on the February, then it will not give me any response, because as I mentioned, cold data is not searchable, and if we have to search, we have to move into the ultra warm tier. So I will show how you can move those data, but before going into the cold storage, this is the API which you can run to migrate the data from hot tier to ultra warm. So anyway, automatically this data will be migrated using the ISM, but if you want to forcefully migrate any particular index from one tier to other, you can run the API like post underscore ultra warm migration, then your index name, then underscore warm. This will migrate your data from the hot to warm. Then we have the status API, where you can check what exactly is the operation going on. So once that is completed, it mentions like it does not have any active migration. So that means data is already migrated from the hot to warm. And now if you refresh the hot tier page, you do not see any data for 21st. But if you go here, you can see the data for the 21st has been migrated to the warm. So what if you want to perform any write operation or indexing operation onto the hot index? So in that case, as 23rd data is there into the hot tier, you are able to run all the operations. But what if you want to perform some indexing operation, or if you want to update some data onto the ultra warm data? So I have 15th of June data, which is actually into the ultra warm. So you can see I have this index into the warm tier. Now if I run any indexing operation, so I get like this index has read only delete block, so that means you cannot perform any write operation. But if there is any need where you really want to update any data or index new data into the warm tier, you can run the API to move the data from warm to hot. And once that is migrated, so basically it has different stages, like it will perform the force merge, and then it will do the sort relocation and everything. And once you see that data has been migrated, then you can run this particular command to index the data. But as of now, if I look at the status, it's not yet migrated. So let's wait. It takes a couple of minutes to migrate the data from the warm to hot, because now the storage is changing from the S3 to the your hot storage, which could be EBS or the instance storage. So let's give a couple of minutes, and we will come back to this later. And by that time, let me show you the cold migration. So now you have the data on the ultra warm where you can perform the search. So here it is, like you have data for 4th of April, which is into the ultra warm. You run the search, it works fine. But now if you have some data which you want to migrate from warm to cold, or if there is some data already into the cold, then you should not be able to run any search on that. So this is the API to move the data from ultra warm to cold, and you can run this API. And after moving the data from ultra warm to cold, if you run the query now, then it says there is no index like Octane IoT logs 2022-44, because this data has been migrated to the cold tier. And if you go to the cold tier and search for 2022-0404, so now I have this particular data into the cold tier. So you can see the index name over here. Sorry, let me, yep. Yeah, so it's 2022-0404. So this data into the cold tier, that's why you cannot perform any operation. But what you can do is you can again move this data back from the cold to ultra warm using the API as well. So I just specify the index name and the API for moving the data into the warm. And once I run that, it migrates those data to the ultra warm. And now if I run the search, I can see the query. So this is how you can use the API to move the data from one tier to other. Then at the same time, you can use the UI as well to move the data from warm to cold or cold to warm. So like I can move this data from say 16th of June data to the cold tier. You can use the UI, you can select the timestamp field and move index. It will migrate those data. And then what you can do is you can also move the data from cold to warm if you want to run any search at later point of time. So you can use the same UI to move the data from cold to warm. So this is how ISM policy works, and this is how API as well as UI also can be used to migrate the data from one tier to other. Then let me show you a quick example of the dashboard what I have. So I have a data of coming from various fleets or various devices, and by default say I'm loading the data for last 24 hours. So it loads the data, and all of these data is coming from the hot tier or the hot indices. But I can also do the last, okay, so for the hot tier for last 24 hours, you can see the timing is from 12 to 9, basically talking about 24 hours. And now if I do the last 7 days, so I just want to show like you can use the data stored into the warm tier for doing all sort of interactive visualization and dashboard as well. So now if you look at the time frame, so as data is now coming from the warm tier, so it might be a little bit slow for the first query because it's fetching the data from S3 and caching it into the local ultra warm nodes. But anyway, you can see you are able to run the query on last 7 days worth of data, where your 4 days of data is into the hot tier and 3 days of data is into the warm tier. But you can see the, so there is no issue of accessing the data at centralized place, and you can see everything at one place. So this concludes the demo. So let's get back to the slides where we left off and talk about what do we take out from this particular session. So in a nutshell, You can use your hot tier for the faster access, which requires the low latency for your data. Then you can use the ultra warm to store large amount of read-only data with low storage cost. And then you can use the cold storage to extend the life cycle of data, which might not be queried too often and just needed for some regulatory or the compliance purpose or like an archival purpose. So this concludes a quick overview of storage tiering. And if you would like to know more about ultra warm and cold storage, or you have any questions or looking for a demo, so please check out our Getting Started page, and you can find all the details over there, like how you can start your Amazon OpenSearch service. And then thank you for listening, and feel free to reach out to us if you have any further questions.